All right, let's go ahead and get started. Got lines to talk about today. My job is to get through this in one lesson. The assignment is 1 through 53 every other odd. So we are going to get through this, and it's going to be a lot of fun. I haven't seen this lesson since last spring, a year ago. So it should be interesting. Hopefully it all comes back to me pretty quick. Yeah, that's the last time I taught 124. See, it says 124. It should say 126. So anyway, pull out and dust it off. Lines. There's all kinds of lines. Lines with positive slope, negative slope, no slope, and zero slope. All types of lines. In calculus, you're always looking for zero slope and no slope. So we'll probably start out with negative slope and the positive slope to try to figure out what is when we get there. All right, lots of ways of doing it. The equation of a line. We said there were two equations the other day. AX plus BY equals C is a general equation of a line. Normally for x and y intercepts, I don't work a lot with that. I'm more of a y equals mx plus b because it's calculator ready. If I want to see something, it's ready to go into the calculator. All right? When you sketch a line, I don't know, you got x intercepts, y intercepts, things like that. The topic doesn't really change, just the examples change. X intercepts, y intercepts. You know, is it positive, negative, zero slope, or no slope? All right, that has to be conveyed in your sketch. Can you put these on the calculator? I suppose, but you still have to be able to do it without. So, we've talked about slope before. The definition of slope is y2 minus y1 over x2 minus x1. That's pretty standard. I'm going to give you this definition also, delta y over delta x. That means the same thing. Change in y and change in x. And I'm also going to say, I think I'll just stop right there. I won't give you too much at once. Okay, so change in y over change in x. A line parallel to the y-axis has no slope. That's pretty obvious. Parallel to the y-axis has no slope. And up here, I think it says parallel y-axis goes through point. All right. I think that's the textbook definition. If two lines are parallel, obviously they have the same slope, right? If two lines are perpendicular, do you remember how we said their slopes were related? Yeah, they're opposite reciprocals. So if you multiply the two slopes together, it would equal -1. They're opposite reciprocals of each other. Lots of ways of looking at it, lots of words, things like that, to make sure that you can, understand all the different questions they can ask. So, I think everybody knows slope. It's hard to do on the calculator because you have to make sure you use parentheses if you're going to try to figure out slope that way. This one's pretty cut and dry. That's kind of boring, actually. If you go over 4, 3, 4, and you go down 2, you can make a dot for A. And if you go back 3 and down 2, then you have to draw it out. That's ridiculous. This is going to be a horizontal line, isn't it? So what type of slope does a horizontal line have? Yeah, zero slope. Oh, that's pretty easy. Y equals 0x. And where's it going to cross the y-axis at? Yeah, -2. So it's going to be y equals 0 plus -2. Y equals -2. So the slope is 0. The equation is y equals -2. Because on your multiple choice test, it's going to have y equals -2, x equals -2, y equals 4, x equals 4, all kinds of choices. Don't second guess yourself when you know that. And if you really don't see what's happening, you can always take the difference in y's over the difference in x's. Okay, 0 over -7 equals 0. All right, that was pretty easy. Probably a waste of everybody's time. Use slope to show the points of the vertices of the specified polygon. What is a geometric definition of a trapezoid? Geometry. I love it. I teach it this fall, as a matter of fact. Anybody know the definition? Yep, go ahead. Yeah, it's a quadrilateral. It's one set of sides that are parallel and the other are not. Okay? And what do you call those sides that are parallel? The bases. Base 1 and base 2. I don't know. Just go 2, 3. I don't know which sides are going to be which. 5, 1. 1, 2, 3, 4, 5. Negative 1. 0, negative 6. Oh, I'm still not sure what the bases are. 1, 2, 3, 4, 5, 6. And it looks like negative 6, 2. 2. This is D, this is C, this is A, and this is B. So I'm guessing it looks like AB might be the bases. AB might be a base, and CD might be a base. Oh, nice crooked lines there. That's all right. I'm at a bad angle. It's a bad angle. Anyway, 5, negative 1. So the slope of AB, I'll just put an M in front of it. The slope of AB, I don't know, 3 minus negative 1 is 4. 2 minus 5 is negative 3. Yeah, if I subtract the y's and subtract the x's. Over here, D is negative 6 and 2. And 0, negative 6. So the slope of CD is negative 6 minus 2 all over 0 minus a negative 6. Let's say negative 8 over 6. Hey, that's the same thing. It's negative 4/3, so they are parallel. Nice. I like it when that happens. And don't forget, those are little markings for parallel lines, the little arrows on the line. Okay? So that's how you show something as a trapezoid, one set of sides parallel, known as bases. We won't worry about that. Like I said, I'm trying to get through lines pretty quick. Questions? Slope? These are pretty easy. Sketch a graph of y equals mx for the given values of m. Yeah, y equals 5x. It's not too difficult. When it's not given, what do you assume the y-intercept to be? Yeah, 0. So I make a point at 0. That's the b part. And the m part is y. And what's two words from geometry you remember for m? Yeah, rise over run. Rise is actually the up and down component, and run's the vertical or the horizontal, component. So I go up 5 from that point. And I go over 1, I make a dot. And I connect them. Okay? I connect them with a really fat line. How's that? Okay? There we go. That's horrible. I'm not letting that stay. See, I was trying to be nice to the people watching the video since I'm not here. I'll just pick it up. 1, 2, 3, 4, 5. And you connect it with a line. A lot easier. Okay? I don't know, not much to that. Probably why I thought I could get this done in a day's time. I'll get to the calculator here in a little bit. Slope equal to a half. I don't know. It means you're going to go up 1 and over 2. Not quite as drastic as the other one, is it? There's another example down here, but I think we get the idea, don't we? Negative 1/3. That means down 1 and over 3. Okay? So that's all you got to do is just make a sketch, and you'll be fine. I don't know. Doesn't look that difficult. It's not that difficult. Oh, this equation, the point slope formula. I never use it. If you want to use it, go ahead. Do you see how they got the equation? Well, don't write it down yet. Yeah, all they did was they took x minus x1 equals m, and they multiplied it over. And for this one, you obviously need a point and you need a slope. The reason I don't like using this one, a buddy of mine said there's too many chances for mistakes. If I have a point and I have a slope, I put it into y equals mx plus b, and I solve for b. I always found that's less chance for error, especially when you distribute, especially if you have a negative slope. So that's how I do it. That's up there in case people want to remember what is the point slope formula. But if I have a point, I'll put it in for y, and I'll put it in for x. Then I'll put in my slope, and I'll solve for b. That's how I do it, and I'll write my answer. Y equals blank x plus blank. There's actually another way of doing it, and I'll show you that probably off the video, that I would really actually do if push came to shove. Okay? But that's how I would do it. Write the equation of these lines. The hardest thing about these problems, as I recall, last time going through this book, we're just trying to figure out what the heck was being said about the lines. Looks like negative 1, 2 is on the blue line. So on the blue line is the point negative 1, 2. And it looks to me like the slope for the blue line is you're going to go over 4 and up 3. That's what it looks like to me if you're on the blue line. Does everybody agree with that? All right, so if I don't find the equation of the line in blue, like I told you, I got the point and I got the slope. Equals 3/4. Remember, it's rise over run. So I would just put it into the equation. 2 equals y equals mx times negative 1 plus b. I solve for b, and that's my equation. If you want to do the y minus y1 equals m times x minus x1, that's fine. But on a test, I'm not going to ask you to recite me the definition. I'm going to ask for an application of it. So you can do it either way. So 2 equals negative 3/4 plus b. So b equals 2 3/4 because you add it together. I don't know, if you take 2 plus 3/4, you get 2 3/4. So you end up with y equals 3/4 x plus 2 3/4. Okay? Go ahead and try the red one on your own. For the red one, again, the hardest thing is seeing what's happening. For the red one, you have negative 1 and 2. And for the red one, how's the slope working for the red one? Oh! Yeah, they're perpendicular, aren't they? So you're going to go back. Yeah, you're going to go back 4 and up 3. Oh, okay. So you're going to go back 4 and up 3. That's not a very good picture. Let me do this one. Negative 1, 2, back 4, up 3. So that's where the negative comes in. They're a right angle. Wait a minute, that wouldn't make it perpendicular, though, would it? Yeah, if you're at this point, you go back 1, 2, 3, 4, then up 1, 2. Yeah. So you go back 4 and up 3. So they're not perpendicular. I need to take that off. All right, so go ahead and find the equation of that line. Another way of looking at it is down 3. All right. So go ahead and give that one a shot, see if you can come up with it. Again, if you want to use point slope, that's fine. Y equals mx plus b is fine also. Clickers will be coming out next month. I don't know if you've ever used clickers before, but I'm excited about it. Kind of gets people up off the couch and gets them moving. So everybody used the point for the red line of -1, 2, and the slope of -3/4. I'm going to use y equals mx plus b. All right, everybody get an answer? Good. What'd you get? Everybody get -3/4 x plus 1/4? Good. Pretty easy. Yeah, I don't think I'll go through it. I think it's pretty easy. 2 equals, I'll just start off in case somebody has a question. And I'm not here to answer it. Yeah, you just solve that and you're done. All right. Slope-intercept form. I've already talked about that. I use that for the point slope. This is TI ready. You have a button for your calculator. B is obviously the y-intercept. I say that because a lot of good questions will say this is the y-intercept. And the slope is delta y over delta x. I don't know where I learned that yxm solved for b, but I don't know. It's probably commonly taught that way. All right, let's have some fun. Sketch lines on the same coordinate plane. Well, this is fun. I think we all know how to do this. I only got the calculator and sketch them. That's what I'm going to do. So go ahead and get your Smart View. And go to the y equals. 2x plus 3 is the first one. Y equals. Make sure that you are in function mode. In fact, make sure everything's along the right. Or left, I'm sorry. Make sure everything's along the left. Then we'll go to y equals 2x plus 3. So far, so good. And then go to -1/2 x. Depending on the make and the model of your calculator, I always put fractions in parentheses because it might take the x and put it in the bottom annoyingly to you if you're not careful. If you type in -1 divided by 2x plus whatever, it might suck it in the denominator. 82s or what? That was one of the flaws they had. So then I put plus 3. And also, one thing you have to understand when you're graphing a couple lines, you can tell them apart because one has a positive slope, one has a negative slope. One should be going down, one should be going up. And also, you can take your left cursor arrow and go all the way back and make one a thick line and make one a thin line. Yep. I haven't done anything yet. How can I say error? All right, if it says error, press go to. And that's a minus, not a negative. Okay? Yep. Oh, I went back. I used my left cursor arrow. Then I pressed enter. Yeah. Oh, you want to see something really cool? I'm going to go up to the bubble. The bubble with a line. In calculus, we do bubbles without lines because we're like tracking planes. And we'll see if they're going to, oh, I missed it. We want to see if they're going to like crash. So we do the bubbles according to time. We haven't done that yet, but we're getting ready to. There. So I'm going to press graph. Oh, mine's under, I like this feature a lot better. I am going to change this to simultaneous. I like the time factor. I like them to graph the same X at the same time. You don't have to. It's just a personal preference of mine. And I'll press graph. See, look at that. I like that. You got to have some fun in math. Okay? So that's how you can tell two graphs apart. Sure, you could have done one's positive and one's negative slope. But you can go one thin, one thick. Also, a very common problem, if I press trace, which is the line next to graph, it tells you on the display which graph you're currently working with. I'm currently working with y1. Okay? If I move my right cursor arrow, I can slide. I get a point readout of where I'm at. Okay? So everybody see the X and the Y, see the difference? If I hit my top arrow, watch what happens. It jumps to the other graph. Okay? So you can jump between graphs. If you had 3 or 4 graphs at one time, you could jump between all 3 and 4 graphs between, to see what's happening. Another interesting thing is usually solving equations. I'm going to do this really quick just for fun. I want to see where the 2 lines intersect just for fun. So I'm going to go to second, calculate, intersect, which is 5. The calculator is asking, what's the first curve? Well, it's y1. I say, yes, that is the first curve, y1. Is that the second curve? Is that y2? And it shows me, is that y2? I say, yes. And it says, what's your guess? I don't know, my guess is around 0. I just type in 0 and I press enter. And it tells me they intersect at the point 0, 3. Yep. Second, calculate, intersect is where I went. I know we're not doing it, but I always take opportunities to bring things up in the flow of the lesson, so to speak. And when you're talking about lines, usually you talk about intersecting lines, and that's the way of doing it. Okay? So, nicely said. I'll put this on the notes. Somebody say, well, why'd you, it doesn't say, well, too bad. Okay? I felt like doing a little extra, nothing wrong with that. All right, that's how you sketch out the graphs. I'm sure you can use 0, 3 and things like that, but, that's how to do it. All right. The general form of the equation we talked about is ax plus by equals c. That's normally for the intercept of it. But at least you're learning some terminology. That's usually for generating the intercepts. If you want to find the slope, I would just solve for y. Okay. Y would equal negative ax plus c divided by b would be the slope and the y-intercept. Okay. I always revert back to the slope-intercept form. Always. I can't remember last time I won my equation in terms of a general form. The reason you have to know that in case there is a multiple choice assessment and you got the slope-intercept form, you got to know how to find the general form. And it's not that difficult. Multiply the fractions, get the variables on the same side, and you're done. All right? Okay. I don't even know how much I got left. Oh, yeah. I'm in good shape. I'm in great shape. Find the general form of an equation of a line through point A that satisfies a given condition. I like these questions a lot. In fact, in the old textbook, there are 45 of these questions. I think I used every 45 of those questions throughout the year. On this quiz, on that quiz, this test, that test, on the final, at the end of the year, in the middle of the year. I love these questions. They're great thinking questions. With that said, did you get an answer yet? Oh. The point A is at negative 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. There's the point A. It says it has to go through A, but it has to be parallel to the line x plus 3y equals 1. Parallel means same slope, correct? What's the slope of x plus 3y equals 1? We just did it. Yeah, it's negative 1/3, right? 3y equals negative x plus 1. Y equals negative 1/3 x plus 1/3. So the slope of my line is negative 1/3. Parallel means that both slopes will be the same. Slope of my new line, negative 1/3, and the slope of my old line was negative 1/3. If it just asked for a sketch, that wouldn't be so bad. I would go down 1 and over 3. Right? And I told you I could take the point 5 equals m times x plus b. I like to do that whenever I find the equation of a line. Now, you can adapt that, but that's what I always like to do. So b5 equals 1 plus b. B equals 4. Anybody else get y equals negative 1/3 x plus 4? Or am I the only one? Is that what you got, Michelle?
Yeah.
Good. Y equals negative 1/3 x plus 4. Nice. Oh, the general equation, I forgot. I always stop there. Okay. To find the general equation, multiply everything by 3, clear the denominators. 3y equals negative x plus 12. Add the x plus 3y equals 12. Okay? Thanks. I probably should leave it like that since that's what the directions ask for. Hey, fantastic. I love those questions. Parallel, perpendicular, they're all fun. Okay? All right, moving on. I asked this question, and over the years, I'll bet 50% of the kids get it right and 50% of kids get it wrong. I'm stunned. I think it's the easiest question in the world. It says, find the slope-intercept of the line that satisfies the given conditions. An x-intercept of negative 5, and a y-intercept of negative 1. And I always get the same comment. I just froze. I didn't know what to do. I don't believe it. So try this one for, I just want to see if I can get more than 50-50 in one question. So try this and just see if you can come up with it. I'll walk around and answer questions if you have any. Yeah.
So the slope-intercept, is that just the regular slope?
Yeah, slope-intercept form means y equals mx plus b. Okay? I'm hoping for 75%. Get it right. Nice, confidence. I like that. What? Back there. Nice. Did you get it? Nice, we have an answer. Did you get it? Nice, we have a no answer. Did you get it? Nice, we're working on it. Did you get it?
Yeah.
Ooh, a little hesitant though. You picked up your pencil again. Nice. And I know you're rock solid. All right, let's see what we did. Ready? All right. X-intercept of negative 5. That means it's negative 5, 0 is 1 point. And the y-intercept is 0, negative 1. Now, I'm sure everybody in the room knows that the y-intercept is the same as the b. So in this case, I can put in an x, I can put in a y, and I can solve for m if I wanted to. Or you can just graph it. Or you can just do the calculations for the slope, right? All right. I'll just go slope. Negative 1 minus 0 over 0 minus negative 5, right? Negative 1/5. So my answer is y equals negative 1/5 x minus 1. I need 3/4 of it. Nice. I think I got there. Good. I feel better. So y equals negative 1/5 x minus 1. Plus 1? The y-intercept, I think, is negative 1. Oh, that's okay. If you thought that, that'd be fine. See, I read this as negative 5, so I read this as negative 1. Okay? All right, let's move on. I like these questions a lot. I'll show you how college kids do it later, if I have time. The general form of the equation of the perpendicular bisector of the segment AB. Find the general form. Which form is that? Yeah, the one I really don't care for, but it's not a big deal. You're getting confused? Oh, ax plus by equals c. A is 4, 2. I think we did this question once, didn't we? Negative 2, 10. 210. There's B. Oh, I remember. Perpendicular bisector conjures up two pieces of information, doesn't it? The bisector means what? Right? Right. And we use our geometric term midpoint for that. Father of geometry would be proud right now. Midpoint is where you add them together and divide by 2. So it'd be 1 and 6, right? 1 and 6. Does that look right? All right. So it's the point 1, 6. That point actually lies on the perpendicular bisector. What's perpendicular mean? Yeah, opposite reciprocal for the slope. So the slope from that, well, this is 6, and this is 8 with a negative. So the slope of that line, I just took, 10 minus, actually I did it the other way around. 2 minus 10 and 4 minus negative 2. So that'd be negative 4/3, right? And the slope of my line in green would then have to be what? Yeah, 3/4. I did that backwards. That should be in blue. I took the difference in the y coordinates, 2 minus 10, I got negative 8. And the difference in the x coordinates, 4 minus negative 2. So the slope of the blue line is negative 4/3. The slope of the green line then has to be 3/4. Nice. Oh, got my slope, got the point, and I find the equation ax plus by equals c. Trying to figure out if there's a way to go straight to that or not. Probably not. How do you guys find the equation of a line? How are you taught to do it? With the quotients? Where you set two fractions equal to each other? No? Does anybody, you guys don't remember how to find? Okay. I'm just going to go with 6 equals 3/4 times 1 plus b. So b equals 6 minus 3/4. B equals 5 and 1/4, right? Or the mix, that is the mixed number, or the improper fraction, 21/4. Yeah. Seems to work all right. So I got y equals 3/4 x plus 21/4. Clear out the denominators. Going for the general form. See, some people subtract 3x. Some people say you can't have a negative a. And some people say you can have a negative a. So I'll just leave it as that. Negative 3x plus 4y equals 21. Yeah?
Well, what would you do if you had a negative a?
Well, then it becomes 3x minus 4y equals negative 21.
Okay, then negative b.
Yeah. See, a is first. Ax plus by. Some people say you have to have a positive a for general equation. And this book never, or general form, this book never said that. So I was kind of confused as to why they would leave it not negative. But it's not really that big a deal, I guess. You can just run the negative through. Am I close? Oh, I got so many slides to choose from. That looks easy. That looks easy. Oh, the equation of a vertical line is it x equals or y equals? X equals. X equals negative 2. I'm not going to do that one. That looks easy, right? The y-intercept is 0. So y, yeah, 4/3 x. That's almost an insult to the intelligence. And that's in the 40s. I mean, come on. Let's get to the words. Find an equation that, okay, we knew this one. How much time I got left, Keeper? 11 minutes. I can do them both. Oh, yeah. All right, we'll do this one first. Find the equation of the line that is tangent to the circle x squared plus y squared equals 25 at the point 3, 4. I'll give you a hint. This is pre-calculus. That same question shows up in calculus. It's done a different way. So what I'm doing right now is stalling to try to figure out how to do it in pre-calculus while you guys are busy jotting it down. Interesting. Tangents. You have a different way of doing it? What about two ways? Calculus is like right there to the answer. This, oh my gosh. Because you don't know calculus. That's why. All right. There it is. Radius of 5. Right? Centered at the origin, radius of 5. 3, 4, is that on the graph or off the graph? That's always the first question that you have to ask yourself when it comes to a tangent line problem. Oh, contrary, mon frere. It's on, I believe, isn't it? What is 3 squared? 9. 4 squared? If it's equal to, that means it's on the graph. 3, 4. So it is on the graph. That's good for us. The father of geometry always made this point very clear because I heard him every time he got to this topic. What do you know about a radius and a tangent line? They are perpendicular. That's a key fact between the radius and the tangent line. They are perpendicular. This is the point 3, 4. This is the point 0, 0. It should be easy to see what the slope of the line is, shouldn't it? 4/3, right? Yeah. So if the slope of the radius is 4/3 from the center of the radius, what's going to be the slope of the tangent line then? Yeah, negative 3/4. I like problems like this. Little interesting stuff, little geometry, a lot more geometry in the old book. Slope is negative 3/4. My point is on the circle and the line at the same time, so I can use that along with this to solve my equation. Y equals mx plus b. So 4 equals negative 9/4 plus b. If I add it, you can't write b equals 4 9/4, can you? 9/4 is how many fourths? 2 1/4, isn't it? Yeah, so 4 plus 2 1/4. Yeah, 6 1/4 equals b. So, or if you want to get fancy, 25/4. So the answer to the question, y equals negative 25/4. Is that right? I like that. Nice question. Work your way through it. Remember a little geometry. Life's good. 7 minutes left. Is 7 minutes enough time to accomplish? 6 minutes left. Is that enough time to accomplish the salinity of the ocean question?
Wait, it's gonna be something like this.
Oh, so salinity. Oh, oh, come on. Approximate C if S is 0.35. What do you do? Yeah, you put it in the equation and solve. You read all the words and got all negative about the problem, didn't you? Didn't you? And then you get to the end, it's like, oh, now it's too easy for us to do it. I'm just too tired to read. Most word problems are like that. You get through them and they're not really that difficult at all. In fact, I'll bet the people in the back already have the answer. They probably didn't waste the negative time. They probably just used their time productively and solved it. What'd you get? All right. 177. So when you solve that out, that's what you get. Now, I won't talk about what the answer means because we don't have enough time. But we're doing what page? Page 134? 132? 53? And you're doing every other odd, okay? When it comes time for the homework check, remind me we did every other odd, okay? They said 132, page 132.
So we start with 1.
Yeah, you start with 1, skip 3, do 5, skip. So you should be on, 1 up from the multiples of 4.
1 up.
Okay? All right, that was fun. I knew we'd get through it one day.